So here's a computer sciencey example. So what we're seeing here is like, you know, 3 different versions of sort, and in this case it's sorting with, I think, 20 elements. But if I hit the 3 key, it will sort with more elements. So one of the things you notice is when you start going up to larger numbers that one of these sorts seems to get done faster than the others.
So you're saying one of them is more quick.
Yeah. I wonder from the name which one it might be. But you know, when you're teaching computer science, one of the things you can sometimes get into teaching, of course, as you guys know who do teach it, is the efficiency of different algorithms for doing something like sorting, and when you have a small number of things, there's hardly any difference. In fact, you know, they all seem to be about the same. Quicksort might even be a little bit slower. But as you go up to 20 and 40 and 100 elements, all of a sudden the difference between a sort that takes n squared time and a sort that takes only n times log n is humongous. So quicksort is already done, and bubble sort doesn't even seem to have gotten started really. Insertion sort seems to be making progress, but you know, slowly. So this is kind of a cool lesson. And the neat thing is, when you go into the scripts, you'll see that like all these scripts are written in GP itself, and they're not very complicated. So let's see, are they in here? So for example. Here are the scripts for bubble sort and insertion sort. And what's making the animation happen is actually this swap down here, which is doing this is a sort of traditional swap operation. You have to like save something in a temporary variable so that you know you don't overwrite it, and then you put one thing in the other, and you put the temporary in the other one. But then it's got here, down here, it draws something in the viewer, and so it redraws that list. So every time a swap is done, it's redrawing that thing, and so that makes it so that the running time and also the animation is sort of proportional to how many swaps get done, which is a good measure of the actual running time of a sort algorithm. So here's, you know, pretty much all the code except for one other thing, which is I made my own visualizer for lists. So this is just a list of numbers from 1 to n. If n is 100, you know, it's 1 to 100. And there's a somewhat long drawing method here, but what all this is really doing, it's computing like where to put. It's doing a bunch of geometry, but the core of it is this thing right here, this fill rectangle. So it all sort of boils down to drawing a vertical green rectangle on this gray background. So I basically made my list visualizer, and okay, I'm an expert, of course, but I did this whole thing, including writing all of the sorts, which I had to look up in Wikipedia, by the way. I did that like in a morning. And I think it's kind of reasonable for a teacher to, even one who wasn't so familiar with GP, to sort of do this in a day or two, or maybe it would take them a day to do the visualizer, and then, you know, another day to do the sorts. So this is the kind of thing you could use GP to like augment a class, even if you didn't have students necessarily write this code themselves. They could explore this example. Here's another one. This one comes from biology. And by the way, all these examples are here in this demos folder. So this is a kind of a classic ecology example. And the idea is that you have a bunch of rabbits and a bunch of grass, and the rabbits eat the grass. If a rabbit eats enough grass, it reproduces asexually, so you don't have to worry about like discussing all of that. And another rabbit appears, and that rabbit starts eating grass. So let me just run this. It's easier to like run it. And let me select rabbit, because it's easier to see. So there's one rabbit right now, and he's wandering around eating grass. And at some point,
HDMI.
HDMI is not going to make sound?
Yeah, you can change the output.
Oh.
There might be a speaker in the projector.
Yeah.
Oh, there is. Yay. Okay, so as rabbits reproduce, they make a little popping sound. I wanted that to happen. So you can see there's like lots more rabbits, but because there's more rabbits eating grass, there's getting to be less and less grass. Now at some point, rabbits are going to starve because they don't get enough grass to even keep themselves alive, and it's rather sad. They turn black and disappear. and they also make a death rattle as they disappear. So this is this classic sort of ecological simulation that is often described with some equations, some sort of differential equations. But I think it's a lot easier to sort of understand how it arises from just these. It kind of arises from first principles if you do the simulation. So what typically happens is, first the grass grows, and then the rabbits grow, and they eat a lot of grass, and the grass diminishes, and then the rabbits start going down as they die out, and that allows the grass to grow back, and you get this oscillation between grass and rabbits, unless, and this does happen sometimes with this simulation, unless you get to this point where all the rabbits die, and that can happen just because a rabbit is wandering around in an area without grass even when there's other grass, and then of course they never come back, and that's called extinction. So lots of ecological topics can be covered in this, and again one can either have students build this, or you can start with this and have students maybe modify some of the parameters. So if we look in Rabbit, we see it's got things like wander. This is the sort of top level thing. It wanders around, that's the motion. It eats grass if it's touching a piece of grass. It spawns if it gets a certain amount of energy from eating grass, and it starves if it doesn't. And each of those sort of sub goals or subscripts is implemented down here. For example, wander is just move randomly. Starve is that there's a health level. Oh, and actually that's kind of a cool thing. We can look at the health of these rabbits by going in their variables. And so let's say look at this particular rabbit, and actually ignore the shared variables for now. So you can see his health it's kind of going down, right? It was 200 something, now it's 100 something. Now it's less than 100. Is he going to starve? If he gets down to 0, he'll starve. Oops, he did. So that was cool that I picked a rabbit that actually starved. Because if the grass grew back fast enough, then that rabbit might have recovered. But anyway, so this health thing drives both starvation, but on the other end, if a rabbit gets over 1,000 in health, then it spawns another rabbit, but it costs him 500 points. But those numbers are completely arbitrary, and you could sort of tweak them to see, well, what happens if he doesn't need to get as much health in order to spawn? Well, maybe you'd get overpopulation and all the grass would get eaten, and you'd get the opposite thing, which is overgrazing, which then leads to the rabbits all dying because there's no. Oh, actually, in this simulation, the grass would come back because it doesn't need seeds. I didn't model seeding. So.
There's seeds buried in the ground.
Yeah, there's seeds buried in the ground. I mean, you have to decide with any of these things how much detail you want to put in and how realistic you want to make it be. Okay, so let me show you one other thing which is close to my heart, which is music and sound. So GP has a whole sound kind of synthesizer built into it. It also has some code to read MIDI files, which if you're not an electronic musician, you might not know. But there's this file format which represents music as a sequence of notes with durations. And so it's kind of like a structured view of music. And then you can use that to drive a synthesizer, but you can also visualize those notes as they play. So if I start this project, so you can see there's 3 voices or 3 channels, 3 different instruments. It's easier to hear that if you switch them to different things. So I'll make the top one be brass, and maybe the bottom one be a bassoon. And if you still can't quite pick out which one, you can turn off one. So this is just the bass part, which I always like listening to the bass line. And then this is the top line. You can see that's the brown stuff that's going by. And finally, this is kind of the middle part. So this is classical music, which, not everybody likes classical music, but you can get MIDI files of all types. So this one is like a sort of, you'll hear this in our movie. This is a Dixieland jazz, and you can get rock and roll. The only thing that MIDI doesn't really represent is people singing, because that's a very human thing. So you can't really do vocal music with MIDI, but you can do all kinds of different styles of other music. So this is a very complicated project, but it's something that students could aspire to make. And it shows off that GP, actually all of this stuff, both the sound synthesis and the visualization, it's all written in GP. You can see the blocks for everything. Actually, I'll show you I'll show you, but don't be too intimidated. There is a lot of code for the visualizer. So originally, like, this was simpler, and then as I started trying to play more and more complicated MIDI files, I had to make it more efficient. And as you optimize things, that makes code more complicated. So my first take on this was I just drew all the notes every time. So for a small score, you could draw all the notes on every frame, and it was fine. Some of them would be sort of off the screen, but that was okay. But as I started trying to play larger and larger scores, then that was slowing down the redraw and slowing down the music playback. So I had to put in some filtering and say, well, only draw the stuff after the sort of beginning of the left side of the screen, and sort of try to just draw the stuff that's visible to the user. And that optimization added some tests and some conditions and stuff here. Like this whole update first visible node is trying to keep track of where the first visible node is, so you don't have to scan from the beginning of the score every time.
Does it actually run for every MIDI file, or are there still files that it wouldn't take?
I'm sure there are MIDI files, like if you take the full score of like a Beethoven symphony, might be too many voices to actually do it all in real time. So there are limits, but it's neat that you can do this. And for me as a musician, it's very close to my heart. So, okay, so...
How long did it take you?
Yeah.
Well, how long did it take you?
How long did it take me? That's a hard question to answer, because like the first version, I was all excited and I did a first version in about one day. But that was not so great, and I didn't have all the controls, and so then I added to it, just like everybody doing Scratch projects. I started with something, and that was exciting, so then I added to it, and then I added more to it, and then I had to optimize it, and so probably I would guess I spent probably a week of time on it.
But that's really fast.
Yeah, I feel like it should be faster, but yes. I also have written these like 10 times before, so.
I just wanted to make a little suggestion about making the sort of playback head in the center a little more visible, because I spent the first couple of minutes of music thinking that it was playing at the left edge.
Oh, because it's too thin.
Very, very
too much
faint.
of a hairline. And I think I was looking at my screen, not the projector, but I think the projector washes things out a bit, so it probably wasn't as easy to see. Let me backtrack a little. Now you've seen some of the things GP can do, and just talk a bit about, just kind of orient you to the user interface. It's a lot like Scratch, so it probably will be familiar. Over here we have a palette. A big difference is that our categories are not color-coded. There's a few that have special colors, like control and operators have special colors, but almost everything else is blue. And that's because we have too many different categories to have distinguishable colors for every category. I mean, you can only... it'd be really hard if we had like 5 different blues, for me at least, to tell the difference between the dark blue and the merely dark blue, and stuff like that. So we decided not to do that. Sort of a workaround for the fact that there are so many categories. If you're trying to find a block, you don't necessarily want to click through all of these. So we have this handy block finder. And so let's say you're looking for something that involves I want to get the mouse X. I'm sure there's a way to get mouse X. And if I just type a few letters, I think even just like MOU, even MO, it shows up in this list, and then I can click it and just drag it out. And when I do that, it actually goes to the category that mouse X was in, because there might be some other blocks in that category, like mouse Y or mouses down, that are related to the mouse. So once I find a block, I can find its friends, and maybe I'll remember this category, or maybe I'll just use the block finder. These panes are sort of resizable. You have to kind of get the mouse over the little border, and then this purple thing shows up, and you can resize them. And this is especially handy for the stage. Sometimes, you saw me when I was showing big scripts, sometimes you want a lot of space for the scripts, and sometimes you want a lot of space for the stage. Oops. And sometimes you want to only show the stage, and so we have a presentation mode. A little trick to know is that escape gets you out of presentation mode. There's also a background menu for exiting presentation mode. But escape is sort of the stop the world, I want to get off button. It stops everything, it gets you out of presentation mode. It sort of hopefully gets you back into a situation where you can go forward if you've done something that's gotten out of control, like making too many clones or something like that, or too many instances. And your whole thing is kind of, too many rabbits, and hit the stop button, or hit the escape button, and you get out of that. Okay, so we've talked about the categories, the palette. This is, of course, where you put scripts. This is the stage. All of that is kind of familiar from Scratch. Even these tabs, there's like an images tab, a sounds tab, a place to put notes. Those are somewhat similar to Scratch. In Scratch, the notes go outside of the project on the project page. But a little difference between these tabs and Scratch is that images and sounds are global. They're not for any particular class. We use the term class in GP rather than sprite, but they're not associated with any particular class, and that makes it possible to share them across classes. So there's all that. So this is probably the part that's the most different from Scratch, this area under the stage where you see these words that might not be familiar to a Scratcher, like class and instance, or classes and instances. And you know, what's that all about? So one thing we can sort of explore is, like, we've got this thing that says instances, and if I hit this plus, I get, you know, another one of these what I would call sprites if I was a Scratcher. So we get another sprite, but in GP we're calling them instances. We get another instance. So now I've got 3 of these. They look like clones, and they are actually very, very similar to Scratch clones. The main difference is that you can talk to any one of these clones, and you can sort of look inside of it. Whereas in Scratch, the clones they're sort of sealed things, and when you hit the stop button, they all disappear. These persist, and you can actually look at them. There isn't like one clone that's special. So for example, if I take this move block and I click on it, it's moving this particular guy. If I pick another one of these from down here, so now I'm on this guy and click move, it's moving that guy. And if I pick this guy, move is moving that guy. You'll also notice this arrow here. That's different from Scratch. And now you sort of see what it's doing. It's telling me which guy am I talking to. And in the case of the rabbits, when I picked one of those rabbits and we looked at its variables, it was showing me the health for that particular rabbit. Not all rabbits, but just that one rabbit. So this sort of this arrow lets you look inside of one particular instance. So you notice that I can kind of select it by here, and it switches the arrow around. I can also option click, yes, option, or alt if you have a Windows machine. I can click on a particular thing to point the arrow at that guy. Especially that's handy if you have a lot of them on the screen, or you want to see what's going on with that guy that's not moving. What's with him. So if you want to sort of debug a particular guy, you can there are a couple ways you can get to him. One thing that students, young, at least kids in like 4th or 5th grade like to do is make lots and lots of instances, and then they like to make them do something, like, so they'll say, oh, okay, like I'm going to make it move and turn, and so that, oops, and I'm also going to make them all start together when I receive go. So they like to do something like this. You get like, oh, look at all my sprites moving, yay! But then they wanted. This came out from user testing. They wanted a way to clear the screen. So I'll hit escape to stop everything, and this clear button takes away all but one sprite. Now there's some controversy about whether it should take away all sprites or all but one. It actually takes away all, and then it makes a new one and puts it there. The reason it does that, for those of you who are educators, is that my theory is, and this is yet to be tested, is that it's always a lot easier to think about something when you have a concrete thing to think about. So rather than thinking about a class as a sort of a controller for an instance that hasn't yet been created, it seems better to think about a class with an example instance that you can do things to, so you can test move blocks and other blocks, and you can sort of poke at that particular instance as an example of the thing that you want to make. Yeah.
Just a question. For me, it was unexpected that when I receive go, I've expected to see the strikes appearing, and suddenly all of the strikes.
Right. Great question. Yes. Why did all of them start going when I received go? So that is basically I kind of went over that quickly. That's basically the when I receive go is the Scratch broadcast mechanism. So when we click the go button here, it's not doing anything special. It's just a shortcut for broadcasting the message go. So I could do something else here. I could sort of say when I receive start, and then the go button isn't going to start it. But if I drag out a broadcast block and I copy start into that, so I could broadcast that. So that's interesting. So what's going on here? I accidentally clicked broadcast several times, and you notice over here this script is saying 4, and it's also going super fast. So what's really going on behind the scenes is that every time I click this and I broadcast, it essentially starts a new thread running for the receivers of that broadcast. This is different from Scratch. And that means essentially we now have 5 threads. They're all saying move and turn on the same sprite, and that's essentially making everything go super fast.
And not only multiple instances, but also multiple threads.
Multiple threads, right. So I don't know, we could change the semantics so that if the thread is already running for that sprite, it would stop and, or not respond to the broadcast. But right now, this is what it does. Initially, we didn't have this neat feedback, which Jens added. And so it was like kids were sort of mystified, like, why is it going so fast every time I hit this? And they thought it was cool, but there wasn't a good way for me to explain it, because there was nothing I could point to on the screen to show them. But now there is this thing. It's like, okay, it's 5 times. And again, the either the stop button or the escape key stops everything, all of those threads.
So Josh, if there were 3 instances and you clicked broadcast 5 times, would the badge say 5 or 15?
I think it's a good question. Let's try it. But I didn't quite totally answer your question, which is, or maybe I have answered it, but I didn't quite get to the punchline, which is when you broadcast, it sends the message to all the instances that are on the stage. And so I'd hit this plus a whole bunch of times, so there were a lot of them. When I did this animate loop, just by clicking on it, it only started running the thread for the guy that I was talking to. Like everything else you do when you're pointing to a guy, it only applied to that. But when I broadcast the go message, or in this case, the start message, it sends it to everybody. And because I had put that start hat there, all of them received that message and said, start a thread going on me doing this. So that's how I got this effect.
And if I want that only the guy with the link, when he receives the go and only here he's turning, how do I do that?
Yep, there's a way to do that. So you can expand this block. So anytime you see one, Snap has this, right? Yeah. But some people who use only Scratch may not have seen this. Anytime you see one of these black arrows, it means there are some optional parameters. So in the case of broadcast, one of the optional parameters is who do I want to talk to? So I'm going to broadcast this to somebody. I could broadcast to a list of things or a single sprite. And I need a way to get myself. So let's see. How can I do that without
the name of the instance?
Let's see if this works. Nope. Yes. Okay. So this is I have to go into developer mode to get this block. Pretend I didn't do that. Let's exit developer mode. I'm going to tell you about developer mode in a second. But this basically lets me send a message just to myself. Or actually, there's another thing I could do here. Oops, I want to try Brian's experiment in a second, but there's another thing I could have done. I just realized I could make a shared variable, like I don't know, my guy, and I could drop this guy on that on the little sort of box that shows the value of the variable, and that actually made a pointer to that guy, and I can see that it's pointing to that guy by clicking on this eyeball. You see that?
Made a pointer to the class.
What's that?
It says it made a pointer to the class. Look in the text box.
That angle brackets means an instance of. Maybe we should change the print string. But yes, angle brackets around a class name means an instance of that class. That's a Smalltalk thing. Could be more clear.
But if we wanted,
Yeah, maybe it's a my modification of a Smalltalk thing. So yes, it could. I didn't want to have to say to determine the determiner by looking at the first letter. So Smalltalk it says and it would say a my class and my class if it was started with a vowel, an elephant or a house. Anyway,
It should say instance 6 of.
or instance of would be okay.
would we not, if we wanted different behaviors for different things, model them by having subclasses or classes to represent them?
Can you have two classes
Did you say
of...
subclasses?
Can you?
No such thing as subclasses
Okay.
in GP.
But you see where I'm coming from? So this thing behaves differently from this thing, so why is it in the same class?
Right, but these guys all have the same behavior.
Okay.
In this case, we can get to like different behaviors, but you would make a different class for something with which you wanted to have different behavior.
Could I create a new class based off of this class? Based off of my
You
class?
can't do that.
Inheritance.
That's inheritance, yes.
Yeah.
So that was, I deliberately left that out. That may be a
But did you say
mistake.
can't?
You cannot. No.
Oh,
That's what I
man.
just discovered.
Oh,
All right. So the idea is that this is between Scratch and and a full blown
And Snap.
and class-based language. You have inheritance, right? Yeah. So that
It's a good in between Scratch and Snap.
it actually may boil out,
But
come down that
perhaps,
way. That might be the
can
best
you
way to
explain
describe it.
the replacement for inheritance? Because you said there is something that could replace inheritance and is more understandable for
Yes,
people
so-
that learn.
What we use inside of the GP system itself is something we call explicit delegation, which is a big word meaning we just tell the object that we want to do something with an explicit message or explicit method call. So, for example, all of this is really getting into details. All of these guys are actually what we call morphs in Smalltalk or in Snap, and so they have. I guess I won't go there yet, but they actually have this morph object, which is an instance of class morph. And when they want to do something like draw themselves or move, they actually send a message to the morph, which knows how to do those things very explicitly. So it means the code is like full of things like morph, move, or move, morph by blah blah blah. So
they are not a morph. They did not inherit.
They have a morph.
They have a morph, and that's a difference between inheritance.
Yes, they have a morph rather than it's part of instead of is a.
But that only works because only one of them is actually visible. I don't know whether it's the morph or the other guy, but only one of them actually shows up on the stage. Right.
Yeah. Well,
If I want a cat to be just like a dog, it only says meow.
right. You cannot do that. Right. Exactly. You can't share behavior between things that are different. You can only do it by copying.
Oh wait, no, that's
but you
only halfway. So the cool thing about this explicit delegation is that they can share a morph. So that way we can have a cat dog behave
only one
like a dog
possible.
because they're both sharing kind of graphic trait,
Right.
And this is how we're doing, blocks that command blocks share traits, as with reporter blocks. So the whole interface is built that way. We have windows and panes, and they all basically there is kind of a hierarchy, a class hierarchy behind this, except it's modeled in delegation. So there is.
Delegation is in principle as powerful as inheritance. It's just harder to think about, which makes me surprised.
So there's two things. You share one thing, but then two things can share.
How easy
the
is it
third
to copy over
properties
properties into a different class? So if you create another class of squares,
There's parts of the
and how easy would it be to copy a feature from the arrow to the square?
There are mechanisms for copying stuff. So like one mechanism is
Would it just be dragging?
Yeah. So if I made another class called foo, I can drag this guy over to foo, and then it's there, just like in Scratch. There's kind of more complex things
If
like
you had more instances of foo, would it go to all instances of foo when you dragged it, or would it go to
Yes,
the first one?
because
Okay.
it goes to the class for foo, so that affects all instances.
Okay.
Let's get. We're getting into. Whoa. We're getting into like the kind of
Is it open source?
complicated sort of like computer sciencey stuff, and I want to do simpler stuff first. So let me back off. Hold on to those questions.
Programmers always want to break your thing.
Yeah. Well, they want to find limits. That's fine. I want to
Let's do
too.
my experiment.
But there may be other people. Yeah, let's do Brian's experiment. I think I just did it. Oops. Hey, that wasn't supposed to. That was supposed to
It
copy.
moved as opposed to copying.
Yeah.
Okay. All right.
Wait. Let's copy. Yeah, it moved. Okay, so I think the answer to Brian's thing is it says 3 instead. So, but the idea is we'll make several instances of this, and then we'll broadcast foo once, twice, 3 times. So it's saying 3 instead of 9.
So the question is now you are one more instance.
However, there's only 2 instances of my class, so you mean 3 instead of 6.
Right, that's a good question. So
Yeah,
what?
except there, in fact, there is one more.
So
instance.
this guy, oh, I see. Yoshiki's right. It sort of reflects the number of tasks running for that particular instance. So I added this third guy. I only clicked broadcast twice.
And this one is slower.
So he's running, and he's running 2 tasks, and these guys are all running 5 tasks. So the number reflects the number of tasks running that script for that instance.
Oh, one of those guys is a foo?
No.
I said this.
There are 4, and one of them is a foo. I think it's that one.
Oops. Okay. Yeah, these are all ignore foo, which I can't seem to delete. But yeah, this slower guy was I added by clicking this later on. Okay, so
If you have multiple instances of multiple classes and you hit clear, what does it do?
it only clears the instances of the class that's currently selected.
So it does.
So it doesn't mean clear everything off the stage. It just means get rid of all the copies of this guy and go back to 1. Okay, so I wanted to talk about, somebody talked about they wanted to see how GP can draw, do drawing. And so this is a difference between GP and Scratch, is that GP can draw its own costumes. In Scratch, you draw costumes
that's
in
ingenious.
editor, or you move something in, but here we can make a program to draw a costume. So typically what you do is you start by saying how big you want your costume to be, so 100 by 100 pixels, and you get something visible, which is this gray rectangle. And then you could do something like, okay, draw a circle in it. So I drew a circle centered 50-50 with a radius of 50. So there's a circle centered in that square. And then I could add some smaller circles, so you get some eyes and maybe another rectangle. And you can see where I'm going with this. I've now made a program that draws a face, but there's something a little funky about it. It still has these gray corners on it. So a way around that is that when you first draw it, when you first make the blank canvas, you can fill that with transparent. So now when I do this, it sort of. Now, the reason it doesn't do that by default is you wouldn't be able to sort of see that intermediate step of, I now have a blank canvas. So I usually start by drawing something inside a box so I can see where the bounds of the box are. And then when I've got it all looking nice, then I put in the transparent and take away the box.
So every sprite itself is also a stage.
if you want to think of something you can draw on, it's a drawing surface.
Yeah.
So it's something you can draw on and manipulate.
And the stage itself?
That's not really true, because if it were a stage, you know, you could also, you can't just programmatically get a pen on a costume, but it doesn't have to be another sprite that draws in the costume.
Okay.
Right. This is basically just doing drawing commands: circle, rectangle, blah blah
It's
blah.
like a separate micro world, you know, kind of for
drawing.
Yeah.
Is this replacing or supplementing the drawing features from Scratch? So is there still like a paint box that you can paint with?
Yeah.
Okay.
It's not as good as the one in Scratch, or at least not yet. And the feedback we've gotten from kids is it's not, you know, it's below par. This is the paint editor. And
that's perfect. It's great.
This guy Phil Bagg, or is it Bragg? Phil Bagg.
BAGG.
In England, tried this out with his what were they, fifth year students, and they all trashed the paint editor in a very polite way, but they basically said, no, it's not usable. We want the Scratch paint editor. So, you know, I did the Scratch paint editor, so it's like, I got to live up to my earlier, you know, paint editor, at least do as good as that.
The good thing is that every GP programmer could make a better paint editor if he wants to.
Exactly. And that's going to be sort of one of our, like, you know, starter projects. Is here's the beginning of a paint editor. See what you can do. But I think for people that aren't interested in making their own paint editor, we should have a better one for built in. Okay, so the cool thing about once you've got something that's programmatic like this, you can do things, you can sort of change things. So I happen to have this other script here, whose purpose in life is to make a changing value. It actually uses sign function. So this my R for radius is changing. You can see it's kind of goes up to like 13 and down to 10, something like that. So I can, actually before I do that, let me drop animate, or put animate around this. So now it's animating, but the face isn't yet doing anything because none of these values are changing. They're all constants. But if I drop in this variable, I all of a sudden, it's look better when both eyes are changing. It still looks kind of weird. So, but the whole point is now you can make a face that actually responds programmatically to something the user does. You know, so you can make a face that's sang along with music or something like this.
Is it fair to say it's more like an SVG than it is a PNG then?
Yeah, sort of. Except with an SVG, SVG is like a list of commands that you sort of recorded. You basically built by using something like Inkscape or Illustrator.
I'm not sure. Yeah, it's pixelated.
But the fact
I
wasn't worried about that. But the fact that the circle is diminishing in size means that it isn't painted onto a canvas. It's an object that's changing its size. Yeah.
No, well, not quite, because it is actually being painted on a canvas. And if I hang on a second, if I take this part out of the loop, you'll and let's see, it's going to be maybe hard to see this.
What you're saying is it's painting yellow.
Oh wait, I've got to do it. Let's see, I've got to do it like I've got to first paint yellow only. And now if I put these in, you'll see that. It's still painting the yellow. I see. We have to take that out.
Yeah.
So they basically it gets big, and then they're shrinking, but they've sort of already written black onto it, so you're not seeing it. So you have to have this fill on here so that it's refilling with yellow, and then
So it's a repaint job.
So it's repainting, and this is the way you always used to do things in the old days before we, I don't know, in the really old days of the Mac, when you wanted to get a window on the screen, you had to write a draw method for the window. So this is kind of like writing your own draw method.
I know the fill function is very complicated normally, and it's also implemented in GP.
Yes.
Or is it deeper outside of GP?
Yeah, so you're talking about the paint bucket fill, which we can see in the paint editor. So if we take this thing right here and we pick some other color and we pick the paint bucket, it fills. Oh, that wasn't a good choice of color. It fills with that color. So the algorithm that does that is written in GP itself. And you're pushing me always towards these more advanced things. But, now seems to be a good time to enter developer mode. So let me put the caveat on the screen. We're entering developer mode. Things may not be less stable now.
Yeah, take the blue pill or the red pill.
Yes, but all of a sudden now we can actually look at all of the code for the entire system, and this is probably the thing that makes GP different from everything else out there, including Snap, which is that it's actually written in itself. And this comes a little bit from my background as a Smalltalk programmer. I got used to working in a system where all of the source code was written in the same language and all of it was live, so I could change anything at any time and it would actually affect the system. Or at least I could look at what was going on. So in this case, there is, oh my goodness, where is it? Well, let's look at maybe at the paint editor, which is there something called paint editor canvas? Okay, so there is the paint editor, which is the top level box, and then in paint editor canvas, I think is something like this, fill area.
Ah,
Okay, so fill area.
there is an algorithm.
No, this isn't yet the algorithm. Flood fill is the algorithm, and flood fill is maybe defined in bitmap, it looks like, because the first argument is bitmap. So let me go look at we should be able to like pick this block and say, tell me who implements that. That's what you can do in Smalltalk, but it's not all there yet. So we could go to, where's bitmap?
Is developer mode available to everyone, or is there a specific?
Yes,
is there a
yes.
version
It's
or-
only called developer mode to make it seem like you're cheating, but it's just always there for everybody. This actually is a discovery we made by accident with the first version of Scratch, which was written in Smalltalk, and I had left in what I hoped was a really secret trapdoor, which was if you shift clicked on the loop of the R and the word Scratch in the top of the window, it would actually open up the Smalltalk development environment, which was still there in the application. And at some point, I sort of leaked that to one person, and he leaked it to a whole bunch of other Scratchers.
Now everybody
and all of a
knows
sudden, there were like 80, not all of a sudden, but over the course of a year or two, about 80 people posted like modified versions of Scratch, and there was a whole little community, they called it Scratch Modders, that would make new versions of Scratch which would have extra blocks or extra features. Some of them went quite far, and one of them is actually now a major contributor to Snap. His name's Nathan, right? And I think he went to, did he go to CMU?
Yes, and then he left CMU and he's doing something that nobody's allowed to know about.
Oh, he's a spy now.
Oh.
Get it?
Yeah, I guess.
I hope
there
he's
was
got a
no
white
idea.
hat.
But I have no idea, actually.
Oh.
His mom has no idea.
So this is the actual flood fill algorithm, and written in GP. As you can see, it's like a pretty long thing. But the way I got this was I had no idea how to do flood fill, but it turns out Wikipedia did know how. So I looked up in Wikipedia, and there was a lovely article with lots of pseudocode, and there were like simpler versions and somewhat more complex versions. So I started with the simple one, and then and then it was like, okay, well, it could go faster if I do these optimizations. It's always a case of, at least for me, I like to start with the simplest thing that works, and then make it go faster or improve it in some way. So I started with the simplest one, and it was super exciting that it worked, but it was a little bit slow, so I added some optimizations. And then I actually went beyond the Wikipedia article and went, oh, I could do something even a little better. I think it's better. So I did a slightly different variation of what was in the Wikipedia article. But here it is, all written in GP, and it actually works, and it's fast, and it's really neat.
So did you edit the Wikipedia article?
I don't think my contribution is rocket science enough to.
It's not about one contribution being rocket science. It's about 100 small contributions.
Yeah.
And 100 small contributions makes one rocket contribution.
Yeah. Maybe I should go put my code back in. I'll have to look and see if it's really an algorithmic change or just more of an implementation detail. It might be the latter.
Either way, you could add it as an edit, and then someone who thinks
I can just paste the GP blocks in. A GIF of the GP blocks.
and then anyone who thinks they know more CS than
can improve it. Yeah.
Yeah.
So actually, while we're in here, I'll show you that you can actually change the system itself. So somewhere in here is something called the project editor, and that's the GP interface itself. And there's a method in here that draws. It just draws this top bar that's kind of gray right now, and that's actually done by making just a kind of rectangle, a new bitmap filled with this gray. So I'll drag that out, and I need to get a color of some sort. So I think I'll go to, I'll just use random color because that'll do something interesting every time. So right now I'm still I haven't saved these changes. So if I, from this menu, pick Save Changes, then I've saved them, but nothing happens until you actually have to redraw this, which I can trigger by resizing the window. So now every time I do that, we're getting like a different color up here. And they're all ugly, so it just proves that my original gray was the best possible design choice for this. So let me, where's gray?
Gray 200.
Yeah, let me get a gray 200. I guess it's under color. Oh, and it actually happens to be in the palette with that. Hey.
John, supposing you've decided that was a better color or a better way to do things, can you save it and keep it?
That's what isn't finished yet. So,
okay.
Oh, it's only for that session.
It's only for this session right now. But the goal is to be able to...
Yeah, that also saves you.
Yeah. The nice thing is right now you can't shoot yourself in the foot.
Yeah.
The goal is actually would be to have another command that you could do, which is save everything that I've changed for this thing, and there might even be a little, it might even pop up a little sort of Git-like thing that says, oh, you made these changes, you want, and you get to sort of pick which ones, and then it would write them back into the library.
So the remix.
There's no change set.
Yes.
There's no change set until now.
No, right.
Even if
and there isn't even a save image.
Yeah.
The equivalent
You
of save
could get
image.
a piece of paper and write down everything that you've done.
Okay. All right. So the hotshots are asking all the questions. Are there people here, educators, or people here who would like to see, something? Are there things you would like to see?
Who is annoyed by this complicated stuff?
Yeah, I mean, everybody seems interested, but I want to make sure that nobody is getting left out of the conversation just because.
Just because we have loud voices.
Yeah, they have loud voices. Exactly.
Yeah.
Right, it's because we're guys.
So speaking, there's two women in the room, and I know one of them is a mathematician. So let me actually do something that I hope you will like. And you've seen this in Snap, but I just want to make sure you know that GP can do this. So let me go back to non-developer mode for just a second, just so I can show you. It seems like there's a lot of blocks when you're in non-developer mode. I think there's something. Actually, I never counted. But there's probably at least 50% more blocks already than there are in Scratch, because there's all these blocks to do things like drawing, like all these, draw, fill, circle, rectangle, colors, working with pixels. There's all this stuff that's sort of extra that isn't in Scratch. So we already have a lot of extra blocks, but when you enter developer mode, you get even more blocks. So now even more categories, they don't even fit, like I've got to pull this down. And one of those categories is functions. Now, you can talk to Brian about how functions should be the very first thing we teach, but I consider them somewhat more advanced than some of the other stuff. I'd like to get people thinking about loops and conditionals and drawing and variables and stuff before introducing functions. So right now it's kind of in the developer mode thing. But what you can do with functions is the same kinds of things you can do in Snap. So let's say let's say I wanted to compute sort of square. So I want to multiply a number by itself. Well, first let me change that a to n. I don't know why. Just one always works with n when you do math. And I want to basically return the square of n. So I want to return n times itself. So I've now got this function, and if I click this block, it just says, oh, I'm a function. So in order to actually invoke this function, I have to do that explicitly by calling it. So I have a call block here, which will call that function, And if I do this, I'll get a debugger. We'll talk about debuggers in a second because I haven't given it an argument. So I have to call it on something. This function takes the parameter, a single parameter. So let me give it a number, like 6, and now I can call it, and it returns the number 36, which is 6 times 6. Yes, it works. Check, is it check?
Yeah.
So far?
Yeah.
Okay, good. Okay, but that's neat by itself, but it'd be really neat to find all, like, the squares of a whole bunch of numbers. And so for that we have map. So what map does is it will do this for a list of things. So let me get a list, which is in the.
I'm just curious about, does it have a name, this function?
No, this is an anonymous function. That's
It's
why
an
it's,
under function
it's so.
at the moment.
Yeah.
Can it be given names?
Well, sure. I could have defined this function here by sort of making a block and calling it square.
Whoa.
So this would let, and then giving it a parameter and call that n, and then put duplicate that.
There's always a preset for a parameter.
Right. So this. And I also want to make that be a reporter. So before I do this, so so I can define a named function, but sometimes you want to just work with unnamed functions. So this is sort of the equivalent of what he calls lambda, or what is called lambda in computer science.
Yeah.
So the nice thing is you can take a function and you can call it on. What I wanted to do was you could call that same function on a whole bunch of different numbers. So if I just put this function in here, it basically takes this list 1, 2, 3 and returns the square of those things 1, 4, and 9. A quick way to see lots of squares is to use this range function. So just by itself, range returns a list of numbers from the beginning number to the last number. By default, it sort of goes by integers. So I can say, what are the numbers from 1 to 100? And that's that. And then I can sort of drop that in here, and now I can get the squares of the numbers from 1 to 100. And yeah, they're all right. So
That's quick.
that was yeah.
I'm still struggling with the third.
Yeah.
Yeah, it's right so far. We'll move to 9 inches.
Okay. So another thing you
ingenious
can
from
do,
math
another
lessons.
sort of classic thing you
They
can
go
do
up in
is you
odd
can
numbers.
you can ask to filter by some function, some Boolean function, a function that returns a true or false value. So this filter will do that. So let me make a new function, and again, for some reason I always want to call them n. So I'm gonna make a function n that uses the is prime. Oh, this would have been a good time to use the search button. I'll use it for that. So return. I just want this return block. So rather than going to that category, I can just type that in. So we want to know is well, first of all, let me try just is prime by itself. Is 17 a prime? Yes. Is 16 a prime? No. Is 2 a prime? Maybe even numbers are all. No. 2 is in fact a prime. So much for my thought that all even numbers were non-prime. 2 is the exception, of course. Anyway, so we'll make this function that returns basically tests whether n is a prime and returns a Boolean, and we can now use that in the filter block. And let's just try it on a small number of things first. So this is filtering. This is basically returning a list of all the things in this list that are prime. So 1 is not a prime. Why is 1 not a prime?
Because it's a unit. So it has an inverse, and so it can't be a prime.
Because it doesn't have 2 factors.
No.
That's
That's a bad
but by the
definition.
definition of prime, it's like it has 2 factors, itself and 1, and 1 is that.
But
I think
they're not
the reason it's defined to be not a prime is that so that you can't say like the prime factorization is it's either 2 times 3 or 2 times 3 times 1 or 2 times 3 times 1 times 1. I mean,
Yeah.
you'd have an infinite number of answers to
There's
that
a whole load
question.
of maths which, if it were a prime, would be hard to do.
Yeah.
More generally speaking, primes are generally defined as numbers which are not units and have certain special properties, but 1 is a unit. It has an inverse, which is 1.
Right, right.
If you multiply it by 1, you get 1.
Yes, yeah, I know, but I think the reason it's like one is excluded from being a prime is because it makes like things like, you know, what are all the prime factors, you know, more precisely defined than it would work. But that's my theory. I'm not a mathematician.
Right, it's not, your theory is right.
Yeah.
So anyway, so let's look at all the like primes in the numbers from 1 to 100, and that looks pretty cool. I can't think of any factors of any of those numbers.
How long does it take if you really got big prime numbers to filter?
Well, okay, we're gonna get there. So one of the questions I might ask myself is like how many numbers are in that list? So let's quickly let's get a count block here, so we can count. Okay, there were 25 primes in between 1 and 100. And so I kind of wonder what's like if I go, let's say if I go from 100 to 200, how many primes are in that list? And there's only 21, but maybe it's just, I expect there to be different numbers. What about 200 to 300? 16. It seems to be like less and less. Is that like a general pattern?
Yes.
So
can we go from 10,000 to 10,100?
yeah, let's try that. Right, 10,000 to 10,100. 11. Okay, so I want to try this for more numbers, and I think the way I want to do that is I actually want to define a little block for doing that. So I'm going to call it count primes, and it's basically going to just return. I always seem to need return blocks. So maybe these should come with a built-in return block. Here, do that. Okay, so this is going to, so if I, and it should take a number which is the starting number. I'll call that start. So it's going to take a number which is a starting number. Maybe a good default value for that would be 1. So from start to start plus 100. Let's, there's operators.
Okay. Maybe you should put them in alphabetical order.
With colors?
No, I think having them in, they're in an order of like most likely to be used initially. So I don't know. Maybe when you go into developer mode, they should be.
The operator is way too low.
Yes, yes.
Compared to say pixels.
But it's right next to variables, which you're likely to need at the same time. There is a theory to some of this stuff.
What's truly exciting about all this is I can see us saying to ourselves, I'd like it to be like that, and I can go make it.
Yes, yes,
I can't
yes.
tell you how thrilled I am with that thought.
Yes.
Even if it's just changing a color or something.
Or just changing the order, or just changing, you could really easily find the code that
You have to
lists.
find out where to do that.
Sure,
Yeah, no.
but I wouldn't be able to begin with any of the other things I know.
Right.
Wouldn't know where to begin.
Right, but somewhere,
Yeah, I've seen where to begin.
you know, somewhere there is a list of the categories, and if you find the method that has that list, you could edit it, so you could put them in a different order. Or you could leave some out. If you only wanted kids to work on a certain set of activities, you could make a version of GP that only had the blocks for those activities. And you know, and that saves people from having to search around in all these different categories or maybe get distracted.
No, that would be wrong. They should be there but hidden. Unhideable.
Well, the students are just going to have to learn to go into developer mode and unhide them themselves.
I would also like, as a non-computer scientist, as I'm doing game design and course design for my company, the reason that we switched to Snap was so that my tech lead could fork the project and modify things like that with the list.
Yeah.
But if I can go in and modify that myself, I mean, I wouldn't know where to begin to fork the project and change it. But if I can do it, actually with the same language and then show the students, it's a massive,
So you
massive
need better browsing.
Yeah,
It's different than
the
text
same
search.
language thing I think is key, because if you wanted to show your students how you modified something and what you have to do is then teach them JavaScript, it's like, well, that's a bit of a distraction. But if you can sort of show them quickly, you know, here were the blocks for this, and there's the change. This is exactly the same language you guys are using, and I just had to like dig into the system to find the right, you know, thing to change. Of course, takes a brave teacher to do that, because once you've given them that key,
Yeah.
they're going to start changing the system themselves, and you'll be you'll be debugging all kinds of things. But just imagine what a great experience it is for them.
Yeah, we focus also on making it real, and if they see that this is, I mean, it isn't, but it's programmed it programs itself.
Yes.
So they can see, oh, actually what I'm doing is a real thing. I mean, GP does this already, you can make an app, but you can program GP with GP.
Yes.
And then they see, oh, I'm not just being put in a box to play with the blocks.
Yeah.
I'm actually building a house. I could build a house out of Lego if I wanted to, kind of feeling. It's real.
Yeah. No, it's like I'm using an IDE written in C to write C code, and it does have this feeling of like you're doing the real thing.
We really had this with kids being told, you're just making something in Scratch, it's not real. That's just Scratches for kids.
Yeah. Did you get that from the kids or from other people?
Get it from a lot of people. The kids also, the students can get ingrained with this, where they've been told this so often that they stop believing that it's real and they don't want to do it anymore.
Yeah, that's what.
Sorry, if I might interrupt. That's why I said, at the last plenary session with the kids, my comment was, don't let people trivialize whatever it is you're doing, because what you're saying is reinforced with my experience, and that's what I said when I was introducing myself as well. The fact that the two things I hear most often are, when I introduce Scratch to my 11 or 12-year-olds who come from primary school, they'll say, oh, we've already done Scratch, as if that was ever possible. And secondly, is when you speak to many computer educators, computer science educators, who are not in a classroom, they seem to think that Scratch or no derivative is able to be advanced. And seeing what you've got there is just...
They cannot
Richard and I have talked about this as well.
I think before GP it was so hard to explain. It lasted hours or days or months or years to explain to somebody that Scratch is the real thing, and they all said it's not the real thing. But with GP you only need some sentence and some clicks, and everybody believes that this is a real thing.
I don't know. I wouldn't be so. I love it that you're also enthusiastic about this, but the same people who are complaining about some blocks not being the real thing will ask, but what's the VM written then? And they say, but it's C, so C is the real thing. So I think this whole discussion about what's real and what's not real is really wrong in so many ways. And as I've explained this morning on the way here, it's like telling a mathematician, multiplication isn't real because if you look inside, it's addition. So so only wimps multiply. The real mathematicians.
Real mathematicians just successful.
The
Real mathematicians look at set theory.
The real thing is machine language.
The question is, John, what's your policy going to be on pull requests from 12-year-olds?
Depends on the quality of the pull request, I guess. It'll be the same as the policy for everyone else. If it's up to the quality, the quality standard.
In many ways, it's an unwavering thing, like everybody else. There is a concept of modules, and some additional features of those you don't have to pull in. It's really an extension. You just dynamically load, so you don't need to pull the master adapter.
That's definitely true. That people will be able to make modules that they can share that are sort of democratized. They can read into GP that add features or change things, and so the core of GP wouldn't necessarily have to be changed. It's a lot like Node.js or Python, where you don't have to get Guido to accept your change. You can make a Python module and put it on the server, and everybody can use it.
Python isn't so modifiable in Python.
Yeah, but it's very extensible.
But
really, can you make syntax in it?
Not syntax, but I mean, in terms of you can add libraries to do all kinds of things. Okay. So I was just looking up that there's this thing about prime numbers, and we sort of were getting at this, but there's this theorem that the density of prime numbers sort of falls off as this equation that's roughly 1 over the log or something like this, x over log x. And we were sort of experimentally discovering that. So we made this function that, so the first 100 primes, there's 26, and then at 1,000, I'm going to go up by factors of 10, 16, and 10,000, there's 11, and I think there's a 6. It actually seems to be falling off pretty quickly. What are we up to, 1 million?
What's the first number where it's 0?
2. Wow, no, that's got to be wrong. You know what? I think that's got to be a bug. There can't be only 2 primes.
From million to 1,100,000.
It's 100 range, right?
Yeah, that's what I'm saying. So when does it first become 0?
I have to say, I don't think we don't have a big number arithmetic.
All right.
But that would be a good thing to write. But I'm afraid that it's going to turn into floating point numbers, and we're going to get false positives.
The question was the first 100 gap in prime numbers.
By the way, I would love to, Smalltalk has big number, arbitrarily large integers, and Lisp too. And the code for that was mostly written in Smalltalk itself, although there were accelerators that make it go faster. Snap has infinite precision. Yeah. Okay. All right.
What about the implementation of numbers? Does it end somewhere, or is it open that you change the class if you use higher numbers or something? The implementation of numbers themselves in GP.
In GP, it's basically integers start turning into floats when they get to be a certain size.
Yeah.
So you can do big calculations, but then you're starting to get the imprecision of floating point numbers. So there's integers and floats right now. There should be integers, large integers, and floats.
And is it limited somewhere, or is it larger and larger?
It's limited by the precision of floating point, double precision floating points, which is 10 to the 300 and something. Oh, by the way, actually, I think she just left for the restroom. But it's a little after 1, and a whole bunch of people said they could stay for an hour. So I hope those of you who have to leave to catch a plane are paying attention to the time. They've already left. Okay. All right. Well, so let's see. So that was an example of functions for our mathematician. Who else would like to see something of special interest? Or are you ready to sort of dive in and kind of start working on stuff?
There's 2 questions. One is about translation.
Nothing yet, but it's capable of being translated. I think once I have more than 1,000 users in some language, like English, I'll be sort of ready. But I'd say at this point, since it's still beta test, and in fact, I'd say it's still an open question whether GP is going to prove itself, whether it will find enough users, because it really is in the same space as Snap. And I especially became aware of this at this conference when Bernat was demoing something, and I went, oh, Snap can do that too? Snap can do like some of the things I thought only GP could do because it's not running in the browser. I thought, well, GP can write a server, and GP can connect to hardware, and Bernat was doing all these things. So I thought some of the advantages that I thought GP would have when we first started the project have been sort of overtaken by progress in Snap, which is great. Snap has really made a lot of progress. But it might be that there's, GP just sort of dies a quiet death.
Really? Do you think? No.
I shouldn't be saying that publicly.
It's open source, so
I'm being too honest as a sort of a...
No, it can't be. Snap isn't implemented in itself. That's a complete difference. There is a field for that.
Okay, I definitely hope you're right, and it's definitely worth trying. Anyway, we'll see. After it's got some traction, then I would love to get some translators to translate it.
Is there already implementation to translate, or do you still thinking about the implementation?
No, and as with Scratch, the first, I think the easiest thing to translate is the blocks. The second easiest is to translate all the menus and the buttons in the user interface. And the hardest thing to do is to flip everything and do right to left languages. So it will probably go sort of in that order.
But to use with children, for English people,
you don't see the point. But for us, there is 2 points that the children cannot go to complex languages. First, because they don't write the right word, and if it is not in their own language,
yes, you've got a great
two
point.
difficulties.
Yeah,
So
you've got a great point.
I think even if some teacher has to make the translation, maybe one file that you can change the block name or thing like that would help just to use it. I
Yes.
think the menu children are easy with open, say they know it. But with the blocks,
yeah.
there is some.
Well, you're giving me food for thought, actually. Yes, maybe I should implement a translation system sooner, and then somebody who really wanted to use it, such as yourself, could at least translate the blocks that you wanted your class to use.
Yeah, because a lot of blocks are the same as Scratch, so the translation is more or less easy.
Yeah.
For the main blocks, for some of them new words, but the main blocks are easy to translate.
Well,
yeah.
If you're, used to writing simple text code, actually it is very easy to translate the main blocks right now. I mean, there is a file and you just edit.
Yeah, if you dug into the file.
No, wait, but in order to translate Scratch, for example, or Snap, you'd have to do the same thing, edit a file and it has all the strings in
you
it,
don't need
all
more
the block
comfort.
names, and just translate it. So maybe we should point out that GP actually is, at that point where you can't do that. It's just a single file, you edit it, and
yeah, that's true.
Yeah, I mean, if you want to not also have the English.
Yeah, you think
Right.
it must have been more comfort, but other don't.
the other file, and then you have it in English again.
Yeah.
Is there a source code, open source?
Yes, sort of. So let me just show you to answer that last question. The file Jens is talking about is this file.
I would be interested in translating into French.
Yeah, so if you actually can do this right now. If you look in, there's a folder called runtime, and in that is a folder called lib, which stands for library, and in that is a file called authoring-specs.gp, and this is where all the blocks are defined, and this sort of second column here is the way the text will appear on the block.
No, the third column.
Oh, sorry, the third column. So if you edit this, you change animate to whatever you want. Yeah. Then it will be in French. So you can do that, and it will change your version of GP, and you can then share. If you just save that file in that folder, you could give people a translated version. So that would be an interim.
So the only implementation that's missing is the ability to switch languages.
Yeah.
Yeah, you just switch these files. You make a copy of this file, keep it somewhere, translate it, and then it could actually be great for your kids, because there's no ambiguity of which language they'll be using. So you'll have.
They only have your translation.
So it would last you only one afternoon to implement it.
That's the possibility.
Implement what?
Implement the switch.
Yeah. Well, for any particular language, it wouldn't take too long to just go through this and translate.
And of course, people like me who propose, and me also, we can start to translate a lot of things, and other people can continue and change all the languages.
Yeah, and this does highlight one of the advantages of a system like this. It's sort of an advantage of open source in general, but in this case, it's nice that it's sort of the language itself, because making these changes doesn't really require. It doesn't require acquiring a new language skill or getting the tools for that language like a compiler and stuff. It's just editing one file.
And my second question was about possibility to hardware to see what we can do for make an extension and to use something else than GP as input or output.
Let's see. So what kind of, you said hardware, what would
I'm thinking about Raspberry Pi, of course, but also maybe with another system in Windows or Linux that you can send data or receive data and use blocks
Yes. So I mean, it already has support for the serial port, which is a good way to talk to a lot of different kinds of peripherals like robots and stuff. So that maybe is already built in. But let's say there was something you wanted like access to the camera. That's a piece of hardware. That would require, right now, writing some C code and actually modifying the virtual machine right now. Although I have a plan for a mechanism where you could make a sort of an extension dynamic link library that you would put in a certain folder. So you wouldn't actually have to change the VM, you could just add your extension that way. So I have plans for making that be extendable. A simpler kind of extension is something where you want to just add a new kind of block to GP. And actually, maybe I could show that right now.
Is that right?
So...
no, that's incorrect. That's an hour behind. That's UK time.
Okay. Yeah, thank you.
Okay, right. So
Sorry.
here, let's say we wanted to create a block, and I'm gonna make it a very simple block so that you can see the process, but it doesn't have to be this simple. So let's say we want to make a block that makes a sprite jump. So what I'm going to do is I'm going to make a block called jump, and it's just going to sort of do the obvious thing. It's going to change Y and change it back. So move by, I'll use this general move by block, but I'll set the X part of it to 0. So I'll move Y by, let's say, to make it really dramatic, 50. I'm going to duplicate that, and I'm going to move it back by -50. And then I also want to wait a little bit, so I'll take this wait block here, put it in between. And yeah, let's see how that works. So here's a jump block. So this jump block now works for this sprite, but if I made even like a new kind of sprite, rabbit's jump, then I could go to the palette and drag this out, and that would make that guy jump. But now I want to share this I want to basically make this a library that I could import into other GP projects. So people don't necessarily have to sort of start with my project. They can just start with their own project and bring this in. So what I first do is I'll go to this block and I'll say I want to export it to the palette and give it a category. So I'll call it, I don't know, dance moves or something like that. And now my palette has this new category, dance moves, and it just has this one block in it. So that's step one. That's like I've made a new category, and now I need to share it. And so, oh, I forgot how do I actually share this? Oh, right. I didn't practice this part of the demo. Right, so I just save this, I'll just save this project, and I'll call it Dance Moves. I don't know if this is going to work, but what I want to do is call it GP extension. So let me see if that actually saved it with that extension. It did. Okay, so now I quickly hit the new button. So I've made a new project. Notice that there's no dance moves category, and so I want to import that thing. Oh, we're still in developer mode. Even from non-developer mode, you should have this this command load extension. So if I click this, then I have my option. I see my dance moves thing. Oh, it should have. Oh well, it doesn't matter. So I import that, and I have dance moves as a category, and I have the jump block, and voila! Whoops! Voila! It works. So this is a way that you could use to, let's say you were a teacher and you wanted to make some blocks to do something with math. You could make some blocks and you wanted to just treat them as an extension of GP. So you didn't want students to necessarily look at the implementation, you just wanted them to use it. So you could make these blocks and put them in a category, export it as an extension, and now this is a lot like the Snap libraries. They can just import that extension and then they get these new blocks. And students can even make sets of blocks for each other and share them. And all of these things are sort of protected by this really cool module mechanism that Yoshiki did, who's not in the room at the moment. Oh yeah, there he is. That Yoshiki created. So if I happen to use the same class names or even the same function names as you, and I import both extensions, they don't conflict with each other. Now it's possible that we each made a block called jump, and if you imported both of those extensions, you have two different jumps in the category that in the palette. They might be in different categories, but it could be confusing to have two jumps. So we haven't totally solved that problem, but nevertheless, they'll function correctly. If you pull the right block out of the right category, you'll get the behavior from that extension designer created, and there won't be sort of mysterious like aliasing or non-functioning behavior.
Another use for the importing exporting that we're using from a game design standpoint, so I try to use a lot of game design principles in my course design, is a lot of games are very highly engaging because you never go backwards. So for students to see that they created a thing, and next time they hate to start new. Mm-hmm. They hate to start from nothing because they feel like they're throwing everything away. And we really show them with Python and with Scratch and newer versions of Scratch and with Snap, that they can really export their work and import it instead of importing a project and obviously very complicated. They've just hidden the implementation and they just have access to what they did. So they've really this feeling of building on the shoulders of building on the work they've done before. Foundation, and they're really developing it. So they'll have a jump, and then they'll improve that, and then you end up with a lot of inheritance, but irrelevant. This works really well with our students.
That's great. So you see a possible use for this mechanism. I had imagined it more for like teachers making extensions, but it's great that it
as a motivating force is definitely something to try out.
It works also for certification with the young children. If you want to make a game and they have to calculate relative movement, it's complicated. So if you make a block and you say you use this one, it's more easy to explain the other part of games.
So that's when I talk about GP as being an extensible language. This is part of what I'm talking about, is that you really can make new blocks easily, and even people who are not too experienced, they don't have to dive into the internals of GP to make some new blocks.
It's like the basics of the micro world idea. Really.
And we haven't added this yet, but I would like to have a mechanism where like an extension can actually take away categories and take away blocks.
We could manually do it at the moment.
We can manually do it, Yes.
You mentioned at the beginning we can make apps that can
great. Thank you for asking me about that. So let me actually open an example project, a demo project. Is it under widgets? Yes, there's a clock widget here. So here's a clock. If I click go, I wonder if it knows what time. Yes, it does. So this is just
okay. I have to go.
Right. This is a clock that's reminding you if you have a flight that it's time to go. But I can turn it into an app by just clicking this export as an app button. And now if I go to my GP folder, I have a thing here that notice the time. It just got made. Clock.app. And if I run that, I get this app running in a window by itself, and I actually could resize that and put it in a corner of my desktop to help me remember not to miss my plane.
Can I hit escape?
That is a real Mac app now?
It is a real Mac app, yes, in fact.
And that would also work with Windows?
It works in Windows. In Windows, you just get a single exe file. This is, as usual with a Mac app, it's sort of a bundle that you can look inside. Linux, it also works.
How long will it last until it's on iOS? I need that urgently.
I know. So everybody asks about that, and Apple makes that really difficult. If you said Android, I'd say, oh, well, we haven't done the Android port, but as soon as the Android port is done, that'll be really pretty easy.
So it's not only the technical thing, but also the law things and so on.
Yes, what Apple does is it requires you to sign your Apple apps, which means you have to become an Apple developer. You have to use their tools to build and sign the app. So we have to come up with a mechanism, and Yoshiki's been thinking about this, where we might basically generate an Xcode project, preloaded with all the source code you need and everything, and you basically fill in your Apple developer ID and certificate, and it
so that
signs it.
Apple don't see that it wasn't made by their tools. It looks like it was.
It would look like it was. Yes.
Okay.
Yes, but then it may still be a problem to get it into the App Store, because it might not. I mean, we're not using any of the Apple's widgets, and so it might not adhere to their sort of standard look and feel guidelines. I don't know how hard that's going to be. There's no look and feel guidelines for iOS.
Oh, good. And Android? So in that pocket in the corner.
Bye, guys. Thanks for coming.
Bye.
I thought we snuck away.
Yeah.
Did somebody take a taxi to the airport?
No, we're not going to the airport right now.
I don't approve.
You're what?
We're not going to the airport right now.
Oh, okay.
Yeah.
If anybody is, because
I'm looking for a taxi to an airport. If somebody wants to go there too.
I want to create a new app in here called Uber.
Yeah.
Where I do Uber for other people.
Quick. Oh.
Yeah. Create an app and then call a taxi.
I've done it 3 times already this conference. So I'm going to make a business Uber.
So is that clock in the corner a full GP? Can I hit escape and get into the editor and all that?
You cannot. No. You might actually be able to hit escape. Let me see. Yes, it looks like escape kills it. That's probably a bug. But I can start it again by doing that. But you can't. Escape does not drop you into the editor. That's actually sort of intentional. So in Scratch, we wanted projects to always be shareable and remixable. But kids after a certain age, they start wanting to build apps like the apps that they see, which typically don't come with the source code. And so we actually, this kind of seals it so you can't easily get in. Now, of course, if you're a hacker enough, you probably can find the source code in there somewhere.
You might. I find this quite sad that one of the properties of a real program is that it's closed source.
Yeah.
It's like I can't see how this works. Therefore, it's a real. Complete machine.
Yeah, but you can make a decision. You can decide if you want to open it or not.
Yes.
And this decision is also freedom. If you are forced to publish, that's no freedom.
Mm-hmm. Yeah.
Yeah. So there you are. Make it a choice.
Yeah. Yep. That would be actually. That's not a bad idea. So it could be that. If you opt in, you can make it so that what Brian says, it includes all of GP, and there's a way to sort of open it up and see the source and get the source out and remix it.
It's also a good way for people to discover the creation platform, like GP itself.
Yeah.
If they've downloaded a thing and like, so we can just turn it around and start changing the...
So that also means that every small program is as big as GP itself. Mm-hmm. It doesn't strip all the stuff you don't need.
This one does, well, no, it doesn't really. Yeah.
Every GP program is at least as big as GP itself.
But you can see that it's not very big. 7.6 megabytes is tiny, let me tell you, compared to almost any app that you can download.
You use Unity once to make any app and you just...
Although that's kind of cheating, because part of that is to translation us into a million languages. What makes other apps...
translations.
What makes other apps big?
Oh. No, Brian, I don't think that accounts for it. That's just strings. I don't think that's what makes them bloated. It's libraries. It's tons and tons of libraries, of which they're only using maybe a few %, but they get the whole library in.
For the imported blocks, you still can access to the code source?
Not yet. I mean, the plan is to be able to open it. So right now, where was my... make a new project and import that guy again. Right now, when you import, when you load an extension, you don't see, you get the dance moves, the jump block, but there's no way in here you're not seeing the class you're not seeing the script. It shows up here, actually.
Even in developer mode?
Even in developer mode. Yeah, sort of, like we didn't want people to get confused between their stuff and libraries that they imported. So right now, but there should be a sort of a switch that lets you, okay, I explicitly want to look into the library and maybe to debug something. So there should be a way to do that. Like I'm thinking some sort of in this pane right here, it would actually list all the libraries, and you could like click an open arrow and see inside of them. Yoshiki has proposed that as a UI for it, but we just haven't built the UI into it. So the way you can look into it is you can explicitly go back and open that dance moves thing, and there's the code. So, oh, how weird that there's this rabbit. Oh, that's right, I forgot to delete the rabbit class when I saved it.
Okay, that's fine.
What's that? Okay. It's okay, yeah, it's just that you have to open a different file to see the source code. But in some ways that's good because it means like, okay, I'm explicitly changing the library and saving it as a new version of the library. Yes.
I don't know, maybe if it's the map, but when I export as an app, the flow ends there. It would be nice if the app popped up, or if I drop down to the folder. Now I can.
Yes, I see what you mean.
Yeah.
So you know where to put that app,
yes.
right?
Yeah.
Yeah, you actually now have to dig. You found it, I guess. But you have to find it in your documents folder.
Yeah.
Good point.
Yeah.
Can you click on operators for a second? So in Scratch, all of those abs, truncate, round, floor, ceiling, all of those things are one block.
Right.
With a pull down. And here they're all different blocks, and we made both of those decisions. So let's talk about why it's different.
Yeah, so it's different audiences. I never know for sure like what are the right decisions, but I can tell you what the reasoning was for the Scratch thing. So the reasoning was originally we wanted to keep Scratch like super simple. So the first version of Scratch did not have sine and cosine, it didn't have square root, didn't have any functions, just plus, minus, times, divide, not even mod, I think, maybe the mod. And some people on the team really felt that was the right choice. They really did not want kids to open the palette and see things like sine, cosine, arctangent, even though those are useful for some projects, because they thought, well, kids are going to see those, or teachers are going to see those and think, oh, I have to teach trigonometry. It's more teachers, it turns out, than kids that are intimidated by these things. But then after the Scratch 1.0 had come out, we saw not one but several kids who really wanted to use trigonometry to the point where they had actually written a Newton's method approximation for sine and cosine, or series expansion. I forget.
I know such project with that. Yeah.
But it's like, oh wow, people so desperately, and it was slow and everything. But at least they could implement what they wanted to implement. It was like if some people really want to do that, and these were definitely kids that were doing this. Okay, maybe we should put in this function, but we really don't want it to take up a lot of space, and we don't want sine, cosine, arctangent, blah, blah, blah. So maybe if we put them all in one block with a drop-down menu, it will sort of be subtle and it won't take up much space in the palette. So it was kind of a way of sneaking all those functions in the case of Scratch, sneak all those functions in without them really being too obvious, to be honest. In this case, I actually kind of want to advertise the functions. I want to show people, that you can do these things. And when you're actually using the blocks, it's a little more readable to just have a sine block than to have this block that has a little indented area that says sine with it's less kind of visual clutter to just have an explicit sine block. So that's the reason for this choice is to kind of have dedicated blocks for those functions.
So are you at all interested in backward compatibility with Scratch?
Absolutely not. I mean, it's not similar enough to be able to even think about like opening a Scratch project. So unlike Snap, we don't have to worry about that.
And while we're on the operators page, what is in the top right corner of that? There is a block with a dot.
It's E.
Okay.
E function.
I don't think I'm getting Retina mode on this projector. It's a little sharper on my screen usually. But yeah, maybe. We actually had this problem, Yoshiki. This is another Yoshiki thing with the multiply operator, which was originally like an asterisk. And it was kind of hard to see the difference between plus and multiply. So at Yoshiki's suggestion, we switched to the Unicode, X multiply. And actually, it turns out, I spent the whole time in Amsterdam arguing against this, but now I agree that it's much better. Do you remember? I remember riding on the bicycles around the canal. We also argued about whether asterisks had 5 or 6, branches.
Real asterisk.
That's a wrong characterization.
Okay.
Another question around that. Sometimes blocks are not very useful if you, for example, if you just fast want to exchange plus versus minus and so on, and you have to replace the whole block.
Yeah,
that's very unpractical. Have you got a solution for that?
Right. Well, in Scratch and Snap, there are classes of operators like plus, minus, times, divide, which are sort of substitutable, and they show up in the menu when you do a right-click menu. There's like, you can just turn the plus into a minus.
So they are interconnected because they mean nearly the same.
Well, they're in the same category of operations. They both take 2 operands. Actually, we have a slightly like here. I would say plus could go to multiply, but not to minus because. These 2 operators are commutative, and they also can take multiple arguments, whereas minus is not, because you wouldn't actually know what the parentheses would be, and it would matter. Associative. Sorry. Associative. Right. Thank you. So anyway, but we definitely could, like, all the sign, all the trig functions could be substitutable for each other. Thanks for coming. It's a feature to be added. All the comparison, like sometimes you want to change less than or equal to, or to greater than. Just a feature we haven't added yet. It's definitely a good idea.
Or is it easier to go to text mode to exchange blocks?
Text mode. Let me actually go to, in the context of a project that has a little more code, and a project that I wanted to show anyway. Let's look at this project. First I'll show you the project. So this is a project that manipulates pixels.
Who's that young guy?
And an interesting challenge is like to show kids, although so far nobody has actually risen to this challenge, but to show kids this and say, how do I make that? There's sort of a trick to it, and if you go to grayscale first, you sort of start realizing the trick is to kind of use the gray as the distinguisher between the colors. So it turns out it's actually gets green as an approximation of the gray value, and then it uses different green levels or brightness levels to sort of pick the different colors. But anyway, if you get this sort of thing, well, this is text, this is blocks is not as good as text, it's not real somehow. You can go into developer mode and you get this like cool little switch here. So you can say, well, I actually want it to be in text. And so now you have it in sort of text, but it's even better than text because you can still like manipulate colors like this, and you can actually still sort of move blocks around.
So it's not text.
Well, it's
you just removed the
we call it stealth blocks.
Stealth blocks. you can edit it character by character.
Can you actually write here? Like, could you change an operator?
No, you can't edit it character by character.
So this is not the solution for changing plus to minus or something. or is it easier with
not.
that?
Right, unfortunately not. No, it's you still have to drag the block out.
I thought it couldn't there be a possibility that you type the plus and replace the minus or something?
Well, okay, so here's a possibility here is that we can, just to give you one more option, if you really want it, you can generate text code. So this is really the text code, and you can edit it and you can make syntax errors and try to blockify it, and it won't blockify. There's a command if you select
and you can go back.
If you select some text and you select blockify, it will turn that back. Actually, it's easier to see if I go back to blocks mode. You'll turn that back into a block. Hey.
Yeah, well, only if it's.
Oh, it wasn't in. Yeah, it wasn't. Yeah. Somewhere. Okay, wait. Let's blockify that again.
Okay.
Blockify.
And it pops a new one. Yeah, cool.
So if you really want to, you can work with text. But I think I at least feel that is not optimal. That you actually want.
If you explicitly want to make syntax errors.
Yeah, and I mean not only syntax errors, but language translation is an issue. If you go to real text, it's got to be sort of some language is the sort of the base case, or at least that's the way every translating system I've done. Like under the covers, whatever language Scratch is in, there's an underlying set of opcodes that is sort of based on English, because that's the language I speak. Now, we don't have to show that to users. We have a table that maps those opcodes to something else, to whatever the native language is. But in this case, when you go to text, you're seeing the opcodes. When you go to the sort of stealth mode blocks, as we call it, I also should show you that you can go kind of to intermediate steps with the slider. So here you've got this sort of like, you're kind of getting a hint of blockness, but it's more like text. We haven't really optimized this for readability, but
it's nice that they say that
there's a transition. This was courtesy of, was it David Bao, the son of, Anthony Bao. Anyway, we saw this at a Google Code Fest thing where he had just added this to pencil code, this ability to see it as blocks. His dad didn't think kids would want blocks, and he had used Scratch and he wanted it, so he implemented it. And that's why pencil code has that sort of blocks mode, and you can switch back and forth between blocks and text. Jens was really inspired by that. And so he added that same sort of slider thing to GP.
Yeah, also that as it changes, the parameters and the components are staying in the same place, because we've used several blockly derivatives to convert from blocks to Java.
Yeah.
And of course, there's this big jump, and then suddenly, boom, there's way more text. Where was I looking? Where's my block? And here, the nice little bit of color lets you follow.
It leads you smoothly there.
Yeah, it's like a morphing animation. It's
yes, exactly. And the spacing changes gradually.
I mean, that's because of the padding on the block.
That's actually not, right. So what Anthony did was, take
in place. He had the animation.
He had an animation and something that would take blocks and turn it into editable text code. That's what many do. Kind of, there's this transition showing that the text is actually the same as the blocks, and whereas what this is doing is basically addressing issues that we have when working with blocks, and the issues are kind of visual clutter that some people think this is it's hard to read long scripts if the colors are too saturated, or there are spacing issues that takes up too much vertical space, or editability, like keyboard editing. It's sometimes just faster to type stuff because we have dedicated hardware for that, whereas just a mouse or a touchpad is something that you can only do a single thing at a time. And so the idea was to address some of those things that might work better in text than in blocks by just making the blocks kind of vanish. So it's not about changing the granularity of which part I'm editing of a block. and that part actually was very much inspired by Michael Culling and Neil Brown's Greenfoot Stride editor. That's been kind of, how can we work with something that looks more like text but actually is structured, is textual thing. So that's kind of more the idea there, rather than kind of going to text.
But to go to text, you can go to that workspace. So you got the opportunity.
Well, there's even another one, but so we did some experiments, but the idea really is to try to find a good
compromise,
a good solution for the situation you're in, and so we don't really like the go to full text thing because it's more detached from the language.
And you begin to lose what I call the jigsaw aspect, which helps you to think about how things go together. There's something related.
Oh, here's the animation. We want to give full credit to David Anthony we saw this and we went, wow, that is so cool. So Jens, isn't this the thing that inspired you? Words in your mouth?
Well, that's the one. There's another animation which you didn't show that we put in there that turns the blocks to, the actual text that you can edit.
Right.
So there's another animation, and that's the one that I was inspired by Anthony from. The animation that just kind of makes the blocks fade away. That's an idea of Alan Kay. That's what Webprice about. Like, can we and then gradually turn it so there's a slider. Alan was talking about the slider, and I didn't like the idea, but I said, what the heck? Let's just implement it and see how it turns out. Turns out I like it.
Okay.
Yeah, go ahead.
Well, what I was going to say was that this is in the class for me of issues around aesthetics and functionality and flexibility for the particular learner or particular person preference about. For example, you're having that problem with the asterisk and the multiplier earlier, but it may be that if we just had an easy way to make the text bigger for the kind of person who likes that, or you can change all the colors to grayscales for the kind of person who likes that, or all the colors into a set that fit my particular disability about red-green blindness. So again, it fits me. These things surely are easy to parameterize and to fit somewhere like a CSS thing.
Well, yeah. So to put them in a table and stuff would be a source code change, but the source code is available. So
sure. Maybe I make that control panel.
But I think I actually, at least for size, I think accessibility for people like Michael Ball with who has vision, but it's like it's not. He doesn't have great acuity, so he needs to make things really big, and it would be great. And it's not that hard to do to make it so that you can make the blocks bigger and smaller.
I think being able to mess with that is really helpful.
Yeah. And you're right. I mean, some people don't like colored blocks. They feel like it's somehow.
So it's this notion that there's diversity of aesthetics, like that, rather than the best solution is this.
Yeah.
I've often thought that Scratch should have a mode in which the blocks are grayscale, different grayscale values, and that it would, the people who think it's for babies.
Absolutely.
Right. Well, Emily did a blocks language specifically for doing art, and she thought that artists wouldn't want colorful blocks because they wanted to focus their use of color on their artwork, and that like the colors in the blocks might distract the eye. So she made one that was all grayscale, and it was interesting. I mean, there's only so many shades of gray you can have, but her
50.
That's true. But you probably don't want to use all 50.
No, I wouldn't. No, it's a joke.
Actually, I think it's actually around 256.
There's also.
I think you had another context.
I mean, in terms of visual perception, where they try to just barely notice the difference of two grays next to each other. That's why they picked 256 for the,
So for me, there's
mostly.
What? It's definitive. I know, but I mean, I don't think you. If you go down one smaller to 7 bits or something,
There are several that the human eye can immediately distinguish, but not very.
Well, it's interesting, and different people will have different patterns. And this is what I was coming to say again. There's psychological stuff at work here, isn't there? And cognitive stuff at work at the same time.
Right.
Affective stuff about what we think is business-like rather than childlike. So all kinds of things are at play. That's why having it tinkerable and easy to tinker with may lead to some archetypal. Here's the businessy looking one. If you have that problem, then go
If you want business colors,
take that theme.
Or it may widen the walls. It may make it so that some people who wouldn't use the colorful version, say, okay, I can make it, or somebody will make it available in a grayscale only version, and.
But it's not just about aesthetics, that's what I'm trying to say. It's aesthetics, affective, cognitive, because the colours help me to distinguish syntactically different pieces and really help me make meaning of the thing. So it's more than just preference and what I like.
Yeah. So just a time thing, we're almost at 2 o'clock.
Just I think, I'm sorry, but I would like to throw a question because we have already discussed about that. My question is, this is a big decision design, the class and instances oriented stuff, and I'm really a big fan of the sprite oriented way that Snap and Scratch is doing things, because on the field with kids and teenagers, I really think it fits, and with my mom and with other people like that. So something I really badly want is a reflective, sprite-oriented language. I really think that the community lacks on this kind of tool, and I'm quite disappointed that you choose this direction of class and instances, because my dream is that to see kids using a sprite-reflective-oriented language, sprite-oriented reflective language to tinker inside the tools themselves. And I'm wondering if at some point we as a community could make a sprite-oriented language which, like it's the Alan Kay dream somehow, we have something very interesting. We have I think, a stage where we've managed to find a visual block design which is really powerful. But if we add this powerfulness of reflection on this kind of platform, I really think that it will reach a new level. So my question is, why don't we have a reflective sprite-oriented language?
Well, we have self. So first I want to say it's not fair to say that you are disappointed when the this direction.
Yeah, sure.
I think that's not great. But then the direction we are talking about is sort of taken by self, right? It just didn't have a time spectrum. So instead of thinking that this didn't go that direction, we can think of a different language where that takes the self idea more and try to expand. Right? So it may not be related to GP, but it could be a good idea. But having a more language is just a fun.
Yes. So I think there's two things you sort of said: reflective and was it sprite oriented? I'm not sure. It feels so. Reflective means you can look at the system in itself. I think this is reflective. I also think Snap is reflective. This is class-based, definitely, and not sprite-based or instance or prototype-based. I think that's what you mean by sprite-based, prototype-based.
Visual, I think visual is graphical.
Yeah. So, but Snap feels like it's very close to what you would like. What's different?
It's not reflective.
It's on our list.
Yeah, it's not reflective.
It's like this hypothetical language.
It's not written in itself.
It's like a self.
Okay.
Hypothetical language, like a self with blocks.
Right. Right. Well, there's an opportunity there. And when this source code comes out for the virtual machine, you could possibly use GP as a starting point for that. The difference between classes and prototypes in terms of the implementation isn't that great. There's sort of changes you can make to the UI to sort of focus on that as a different way of thinking about objects. And I'm guessing you would want to add inheritance to the mix, maybe, because it's usual in like prototype-based languages to have inheritance. But so it's possible that people will remix GP itself to make different kinds of languages that are sort of exploring different parts of the overall design space. I myself am not sure about the class's choice, but I want to. You have to try stuff for a while before you can find out if it's right or not. And it hasn't had enough time to maybe in this next year I'll get enough feedback to sort of decide. Classes wasn't right. Maybe the sort of snap approach of prototypes is a better approach, and maybe there'll be a GP 2.0. Well, actually, this isn't even 1.0, but maybe we'll actually change it before 1.0. Hard to tell. Hey, Cynthia. So I was going to say before.
So can I just ask you just one follow-up question? Like, what's the kind of activity you have in mind when you say you want a reflective sprite-based language? Like, is it to bootstrap new languages? Is that what you're interested in?
No, the idea of having a reflective language is, it's really a small talk like. Actually, you have these old teenagers. I'm working with a lot of teenagers. So they have 17 years old, 18, and they are making a lot of very complicated, sophisticated projects. And sometimes they are bothered by the tools by themselves. They would like to add something inside the tools. And myself, as an educator, I would like to add some project management tools in their environment, easily with the same language. I would like to share with them the same language. It's like a French language. We are sharing the same language. It's all about that.
Great. So this is actually, I'm glad I asked you that question. So I think that GP might be way closer to what you want to do. I was thinking when you were talking about self-reflection that we were talking about this context in small talk. And I was wondering, like, who was ever using that? Or like, assigning the instance variables of an object, by instVars add. That's what I was thinking when you're self-reflecting. And I couldn't imagine, meaningful projects that would be fun that would use those things. But if it's about, adding tools and changing the UI, that is an activity we want to support in GP. So it has these two modes, the authoring environment, but you can actually change the authoring environment in the extension level by modifying GP itself, and then Yoshiki's module system kind of keeps the changes separated so it doesn't turn into a monolithic thing that later cannot be divided up. So I think GP is actually closer to what you would like to do. Like in Snap, you have to kind of do tricks to do that.
When I saw GP, I was really happy to see something like that. I was expecting something like that for years. But I'm sorry to say that I was disappointed because it's myself. It's not about your work. You've done a wonderful work. For me, you are the dream team. John, Jens, and Yoshiki. You are a very great team. But my disappointment was about the tool lacks of the sprite metaphor, and for me it's very important because I really think that it's a key feature of the Scratch philosophy. And so what I would like to see is the mix of this key feature like the sprite, this idea of sprite, because it's a tangible object for teenagers and for teachers, for everybody involved in this kind of programmation.
Just one last remark. I'd invite you to look at the source code. What you're looking for is called morph in GP, and I bet you, Nicola, it's pretty much what you're looking for. It is a pervasive idea.
It's so open that you can do yourself the system that you wish.
No, there is in the underlying extension system. There is exactly what you're looking for.
Yeah,
There's this abstraction of something that is tangible that you can modify by means of itself.
Sure, but in Snap, you don't. It's not reflective in the sense that there is no blocks to change the blocks.
Oh yes, there is.
No. Yes, but not like a.
You have to look deeper inside. Then you will find what you're searching for.
Of course.
No,
Okay,
it's
guys,
not the same.
yeah,
It's not the same as GP.
I'd say some people are going to need to go, so we can continue this discussion for sure afterwards. I'm going to be here the rest of the day. Jens and Yoshiki, we're all going to be here. I want to make sure that those who are in the workshop, well, first of all, I'm happy to keep going till 3 o'clock, but it's getting to be, people are getting hungry and stuff, so I want to let people go if they want to go. But before everybody goes, if you can stay just a few more minutes, I would love to hear from everybody. If you got all your questions answered, and if you have any feedback, about, I mean, you've given me some feedback, but if other people have feedback about, kind of where you'd like to see GP go, what's missing, or what, what you liked about it, just plus, minus, and questions.
Wow.
I mean, you might want to. You don't have to go first.
I have to go very fast. And what I'm missing is that I always have to wait 2 years until this workshop. It would be much better to have this workshop online every quarter of a year or something. So my question is, couldn't you say every quarter of a year you do such kind of workshop online and the people can meet, and this kind of workshop is so important for me, but it's so complicated to meet with you and all the others, so can't you do that online some more often?
Yeah, I wonder if it would work, it's just hard to do transportation. I wonder if we could do something like this on Google Hangouts.
Yeah.
That's a
There are better
different thought.
things these days than Google Hangouts.
Yes.
No.
Yes.
Yes.
Tell me later. We tried a whole bunch in our group because we do a lot of remote
New
meetings.
ones every day.
What's that? We tried
ones every
3 or 4, I think. So Hangouts, Skype, Blue Jeans, and another couple of things that require.
I would say because of multimedia requirements, have a look at the options for gamers, because they need to do voice screen sharing, video feeds. They have shareable links in the chat and everything like this.
And can they go up to like this many people?
Yes.
I don't. Yes. I mean, you think about competitive teams up to 64 players. There should be enough, right?
Okay, great lead.
Just don't discount the gamer community. they make great tools.
Discord, I think, is a big one.
This is a really would be my first suggestion.
What is
Discord? Discord. It's called Discord. It's a voice chat.
It's like Slack for gamers.
Okay.
Slack for gamers.
You can open your own server.
Discord.
Discord is really.
All right, great. Thank you guys.
I think you could also do that with TeamViewer or something else. It's only but anybody need a license. I do that more often with other people.
So maybe we can like organize this on the GP forums, like sort of try to. I don't know about every 3 months, but we could try to do one at least every 6
half a year. Everything is better than waiting 2 years for you to come to some city of Europe.
That would be great because I love talking to people. I love talking to people about GP, and it would be great.
5 months, keep it odd.
Keep it on.
Promote metric.
Yes, cool.
The point is keep it weird.
Yeah. Does anybody? We don't have to necessarily go in order. Does anybody?
I would really like to see this idea of developer mode being something that is, it's creative mode. It's ability to modify the actual tool inside the tool. This is amazing, and for people to be able to bring in, this could be an interesting way to facilitate localization and color blindness accessibility options, but also for people to share how they create, not just what they create, what Scratch does very well, but sharing workflows. As someone who's not a professional programmer, watching other programmers and asking them to go slower with their key presses was an amazing tool for me to see how people operate, how people build their own workflow. There are industry standards, but here you have the opportunity to customize.
Yeah, somebody else in our group inside Park, via Heart, sometimes does like live coding with remote live coding. So a whole bunch of people are watching her code and they can like ask questions and make comments and stuff. It sounds kind of wacky, but I mean that would be a way to sort of peek over the shoulder of somebody and see what their workflow is like. And I certainly learned when I was like learning Smalltalk, the best way to learn it was to watch an expert working with Smalltalk, because there were all these secret shortcuts and keyboard tricks, and it was like, wow, how'd you do that? And then they tell me, and then I would know.
You know that Let's Play videos on YouTube, Let's Play, and you should have Let's Program.
Yeah, they have this.
Yeah.
As Jens asked, the thing that I would really love to see is someone's doing live stream coding, and they say, I wish there was a tool for this, and someone in the audience, boop, 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 extension set, boom, tool in. Okay, live stream, keep that, continue. This is what I want to see. That's my
that would be great.
Future imagination.
You know the great joy that it is to be a tool builder, and with your tool you give other people the joy to be a tool builder too, that they can have a little imagination how it is for themselves or for other.
Right. If this really works, then all of a sudden, other people are going to make my life easier because they'll think of tools that I didn't think of, and then I'll start using them. That'll be great.
I think the sharing environment is really focused on content creators rather than tool builders. Speaking with Alden, did anyone else speak to him? He made Diamond Fire, the Minecraft. I mean, really, to see, he created a tool that people spent hundreds of hours building content, but he felt like he was not being himself creative, and he couldn't share so much. And this was really, this is something else we need to share. That this is important and shareable, and people want to hear it.
Yeah, I feel, I didn't have that conversation with him, but I sort of feel his thing. Like, I help make Scratch, but I've spent very little time making Scratch projects because I'm always, adding the next feature to Scratch.
That's not less valuable as I had.
Right. But if I could share my process of making GP, then I'm like able to, that's great.
You know what I want.
Next.
Lexical scope.
Lexical scope lambdas, As people saw, I mean, this is an ongoing discussion Brian I have been having probably for like 5 years. But as you can see, GP has, the first argument was that Scratch didn't have functions at all or procedures at all. Now it at least has procedures. Anyway, as you saw, GP has functional programming in that you can treat a function, an anonymous function, as an object, and you can even apply it to lots of things like using the map operator. So that's 90% of what Brian wants. The other 10% is the ability to kind of refer to variables in the scope of where the procedure was defined, and that allows you to make your own control structure. So that's part of the magic of Snap and BYOB before Snap. But I have this worry that feature is also hard to understand. So we have this ongoing disagreement about whether I should put that feature into GP or not. And I'm not completely against it, but I want to see just how far we can get without it, because once you put a feature in, you can't ever take it out again. So I just want to
kill you.
I definitely would want to try GP for sort of a year and see how things go. And it may be that like demand for it emerges or something.
Yeah, but sorry.
Or I might end up working for Jens and he'll make me put it in as my boss.
Well, but you can think of what GP does is a feature where the outside variables are hidden. But then, you added that feature, and now we may not be able to do that.
Oh, you mean the implicit receiver thing?
No, the variable vectors outside free variables are hidden, but you can see that as a feature. And you can apply what you said to that. It's already
it's hard to change the language design.
The lack of the feature is the feature.
So,
okay.
I'm excited because I can see room for creativity for me in what we've done.
Good.
That's number one to say. And I saw that 2 years ago. I didn't know when I'd get to do it. And even now, I'm not sure I can do it. The other thing I'm interested in is this comparison. I was having a joke with John here that it's now 3-3 snap to GP because there were goals.
Put you on the film.
There were goals being scored on both sides, so it's 3-3 now. So each time somebody said something interesting down that end, we got a goal for snap and a goal for that's not really important. But what matters to me is when I look at all these things, I'm interested in what I call the mental model load for the user.
Yes, I'm totally interested.
And I see at least 4 mental models they need to, if you like, balance in their head and keep in their head as they're working. One of them is the problem comprehension. So with your rabbits and grass, they need to comprehend what rabbits and grass are about, and know, roughly speaking, at least, even if they don't know in great detail what these things are and what they do. They have a programming language mental model, which includes the IDE, which is what we were seeing a lot of today. And they have to keep that in their head. And how does that work? Where do I find the statements? What do they mean? How do they work? And how they work leads to the third mental model, which is of the notional machine. What's going to happen when these things execute in the machine itself, in the computer, as they might think of it. And the fourth one, maybe 5, 6, the fourth one is the microworld that's created. So the problem comprehension and the microworld are connected, but they're not the same. The rabbit and the grass in the microworld and how that operates, and how can I express a rabbit in the microworld space? Now you showed us at least 3 microworlds today. You showed us the rabbits and the grass kind of sprite-based microworld, graphical, visual, and so on. You also showed us a mathematical one where we only played with numbers and there was no reference made to what was over on the right-hand side of the screen, and we just thought in terms of sets of numbers. And the fourth one was the musical one, which did have an interaction with the spritey world, but really only as a way of depicting the musical things that are going on. And I think, what we don't do well is to separate all these 4 mental models when we're designing and discussing the design of these things in order to get them better. To get to the point where your older person can use it casually and get a job done, which is what you started with at the very beginning of this talk. And I think quite rightly, we got delved deeply into all these other things. But how do we get to that point where we open it up to that wider population who can casually come along and write some code quickly and get some job done?
Yeah, good point. Yeah, this is tangential, but somehow just a few days ago I came across a paper actually written by Alan Kay, and thought of he did it, so not many people read it, but that's actually written in like 79 or something. We talked about that a lot, and maybe.
Well, that's supposed to be the point of the box, right? Is that anybody can do it. And this anybody can do it thing has been invented badly several times in the past. I'm thinking about COBOL, right? Was based.
COBOL was probably used by more people than.
I know, but it's terrible. And it's not the case that anyone can use it.
Right. Oh, I see.
Right?
Yeah, no.
And
latex is coming.
HyperTalk was supposed to be that too. HyperTalk was better than COBOL.
Pretty successful,
but blocks, the whole Scratch and family thing, really is great for that. And so I'm not sure what's missing. There's a lot of work for teachers to do, but I don't see what's missing for that from a language provider standpoint.
Perhaps nothing.
I'm wondering, I actually wanted to unpack your question a little bit. Do you think there's sort of too much there, and it would be better to like have sort of just a math micro world, or just so it's because there is this idea. I think it was one of the sessions here with Scratch of just having like a micro world that does animation, and another micro world that does music, and another micro world that does games or something. You could, if you divide things up that way, then you get like a much smaller set of blocks, and it's easier to kind of intuit what the notional machine is from, or at least what the microworld is from what's available in the palette. But it also means if there's something you want to do that's outside of that microworld, like maybe add a little sound to your rabbit simulation, maybe the designer of the microworld thought, well, let's leave sound out because that's not going to be part of this. But we've had this discussion a lot of times in the Scratch group about whether to keep all those blocks or to narrow things down and have maybe several separate micro worlds that are separated from each other. And so far we haven't done the latter. But anyway, is it a micro world design question or
I don't think even really question it. This is how I see the problem of designing effective learning environments, is what I'm saying.
Right, actually,
I see it that way.
I want another piece of picking apart. I feel pretty strongly that the understanding how the machine really does it, until you're really a computer scientist, is counterproductive.
Yeah.
Because the real machine, does all the wrong things. It does mutation, it does sequencing, it does all those horrible things. And if you want to do anything good, you have to set up a stack, right? And so on and so on. And so I'm much happier teaching that inside the machine there are a bunch of little people.
Yeah.
And each little person knows how to do a procedure.
I'm not at all disagreeing with that.
Oh, okay.
I use the term notional machine, and I maybe used it inaccurately. And it was really, what story do we tell about little people was what I meant by notional machine. And then knowing how it relates to the language statement, which I also have to have a mental model, how they actually enact that, what leads to that. Now, I personally struggled with this recently when I tried to write a program with 3 turtles that did something together. They collaborated with each other to make a pattern. And I wasn't quite sure I really understood the parallelism between these sprites.
Yes.
So, I didn't have a notional machine model for myself. Exact enough to solve the problem. I had a generalized one, but I had the 3 little people thing going. But how did these 3 little people decide whose turn is it next? And when did they decide that? I didn't know. So that's the kind of thing.
And that's the kind of thing that's not easily findable. It's
absolutely. Maybe there's
it's buried in a paper somewhere.
But it goes from computer science to computer psychology.
Maybe.
You have to just imagine what's happening and then try and test.
But for people who want to learn and be effective and achieve small things,
true.
They need to do these things. That's what they're learning. So that's what it's coming.
Okay. Let's go.
Any comments? It was really a good presentation to have a complete overview of the different possibilities, and there are some very technical points that are very different from Scratch, and people who will switch from Scratch or Snap to GP will have to learn this thing because it's a not complete different, but there are some particularities, some difference between the two, but otherwise it's a good way to switch on visual programming languages to more technical and maybe text-based languages. So it's a very good thing for people.
Great, thank you.
I don't have a lot to say other than I find it really interesting to listen to the discussion. At this stage, I don't have so many questions as I see that this is something that I'm going to be interested in investigating a bit more.
Yeah.
One that we have just we have a new leaving cert, so the equivalent of the A level in the UK computer science course coming into Ireland. And one of the things that is
Raise the volume.
So we'd have the equivalent of a UK A level coming into Ireland, and there will be that question of graphical programming versus text, and it'll be interesting to see how that comes out. Part of the difficulty with that will be in the assessment.
Yeah.
It will be seeing that text will be much easier to assess than graphical. Though I saw there was some stuff going on yesterday.
Why is that the case? Why is that the case?
Why is text easier to assess than graphics?
But also, I think teachers are very familiar, like current coding teachers are very familiar with text marking. I think at the moment.
Yeah.
yeah. Perhaps that's one reason, but I'm sure there's many reasons. But I think the people making this decision are not always. I wouldn't say that they would be in this room. A lot of the people making those decisions.
And it's also their comfort zone and area of familiarity. So that's exactly the same problem there is with the A-level and GCSE that I'm teaching my students of 15 to 16 and 17 to 18. And they have a strict list of program languages that they can use. And others that are forbidden from using. Principal reason for that isn't because it's what's right for them, it's because the person who's going to moderate the coursework, when it's sent to them, so when I've mapped my students' work and I've got to send it to somebody who sees whether my mark is correct, that person will be unfamiliar with SNAP or GP or whatever it is. They might know Python, that's great, so it's got to be in Python. That's
I definitely think it's nothing to do with the implementation of blocks, it's just the mindset of this is new. I think that is actually, I know in Australia that's I mean, we're having it with coding as well, with written code, but a lot of the decisions are being made not by what is functionally the best way to do it, or functionally, or arguably a good way to do it, because let's face it, we don't know the best way yet. But the people making the decisions are choosing on for an emotional reason. I'm not familiar, this is not familiar, I'm not in my comfort zone, we tried this one.
So it's time to talk about one of Jens's brilliant ideas, except I hate the name, codification.
I hate the name too.
Yeah.
I love the name. Bartolus and Baldus, the three doctors in Bologna in 1088, whatever, when they were commenting on legal text, they were writing in between the lines, and then they were composing kind of these introductions, and that was called the codification.
Yeah, like in the Talmud, but it was already code in the blocks. Is my problem.
Well, no.
But anyway, the point is,
snippets flying around the blocks, and they're putting it together.
The point is, if your government requires Python code, your students can produce Python code if you go through the effort of providing the codification blocks to turn.
In other words, snap to Python
translation.
Yes.
We have exactly. I hope I'm not on the side of the description because I try. In France, we have Python on the upper level of high school. It's just obliged to use it in this year. We have to use
only this year first
Python.
got allowed, or you have to use Python.
They're obliged to use it.
15 to 17, just before the exam, the baccalaureate, the last exam before going to university.
Yeah, that's
And,
sort of like the A levels.
In high school, from before 15, they use Scratch officially. So officially they have Scratch. Then after 15, they officially have Python. And I think that it's exactly what you said. The one who make decisions would have come to such workshops than yours and BGC to see what we can do with blocks, because it's high level computing.
And let me perception that it's simplistic.
Yeah.
Just because it's blocks, or that you can click a button and you can see 20 blocks that are available to you. You don't have to memorize them off by heart. That means by not memorizing them, that might be a fundamental part of what the exam system expects of the kids to know, that print or how you write. How you formulate something is as much a loop, for example, or whether you've got to remember the semicolon.
But how many blocks are in assembly language?
So
there's very few,
Perhaps I can focus the point of this discussion on another thing, not only for teaching, but for programming itself. I think we are only at the start of that what blocks can do, because you can use blocks. You have so many invented things that are over Scratch that you implemented in your blocks. Only small things, switches and other things. And I think blocks can get complex machines where you see in the future that you can do much more and much faster thing with blocks than with text. Until now, every professional programmer says, I'm faster with text because I'm professional. But if blocks getting better and better, and blocks really getting a user interface and a machine itself that programs for you, then there will be a point in the future where even professional programmer says, no, blocks are faster for me than text. You don't believe it, but I think it will be.
No, I'm disagreeing because of my experiences that actually I've been having this blocks to text discussion for a long time. It turns out, we worked in this bubble, John, Ishiki and I, of research, community, not really with actual developers. Now that I'm kind of forced to work with actual real developers, I could tell you that I've not seen a professional developer claim that text is better than blocks. And in fact, the professional developers I'm working with, and I'm showing this, they're all totally delighted and nuts when they see the blocks.
It's the same.
It's not professional. It's people aspiring to be professional developers and thinking that that's how the world works.
But I think
the problem is not the professionals. The problem is the amateurs.
Or maybe the non-experts in this field. Perhaps is a better way.
There's something else too. Lisp programmers are more productive than C or Java or Python or any of those people, programmers. And we're talking about text languages in both cases. And the difference isn't about parentheses versus semicolons. The difference is about the level of abstraction that the language gives you. And Lisp programmers or functional programmers, they don't have to stand on their head to deal with data aggregates because lists are easy. And why are lists easy? Because of things like map, right? And we have that advantage too. So it's not just blocks, and we have other advantages in the way we think about programming.
So Natalie, if you have some time.
I think that people that write about things need to show sophisticated programming examples written in text and in blocks. I don't say, when I was listening to these conversations, I said, well, don't they care about the result? And no, because they go to code.org, my favorite example, which is I write these little things they give you, and I'm marked wrong, but mine does it.
It's because you didn't do it their way. On two strings, that's how you assess.
But I think more has to be said about this from this community. That's it, because you keep hearing that blocks is for babies, and then when you want to be really good, you go to Python non-blocked. There is Python with blocks.
Perhaps we shouldn't have used the word block. Unfortunately, there's a.
I tried to change.
You get your choice of word, haven't you?
What do you use instead of block?
I talked about this several years ago. I'm so cross. Nobody's listening to me at all.
Now they
Why should they listen to me? Jigsaw programming. Call it that, for Christ's sake.
But then it's only for old people. When you're retired.
I tried to change this because I know that the one who decide official curriculum, they don't know all about this, and they really think that Scratch is for babies. And I wrote an article on Snap early April, but it was too late, and I'm not sure that they have written sorry. And this is a thing that the one who decide, they think that people like me, who is in research in teaching mathematics, are some people very, en français on dit embêtant.
Annoying.
Dérangeant.
Deranged.
Oh,
Yeah.
wow.
No, pas dérangé. Dérangeant.
Dérangeant.
They're the troublemakers.
Yeah, trouble.
Really?
The problem is your lone voice. And I say that these people here ought to be writing more to support what you have done and to explode it around the world. Is that? I mean, you know, I didn't know about what you did.
I think the decision can very fast be made if programming with blocks gets faster in productivity than in text. That's not the point yet. Perhaps it will be 10 years in the future. But now you can say the productivity of learning programming is much faster with blocks. But if you sometimes in the future, at the state what I said, blocks are kind of machines, user interface for making programs. And if you some days are there that blocks coding is much faster and more productive than text coding, then everybody will be convinced.
That's one factor.
I think you have to go back, get rid of coding and go back to programming.
Yeah, but this is now. I have to
It
say,
is so
it's scarily
low
fixed.
level.
Yeah.
Paraphrasing that, basically, 10 years from now, if the dichotomy is text versus blocks, we are totally lost. In 10 years, we should have a better programming experience. For sure.
Yeah, I think blocks will get three-dimensional in the future. Not only for optics, but for usability.
It already exists, and I can tell the usability is negative.
Yeah, now.
That's an easy one. That's an easy one, of course. Everybody talks about that. But yeah, sure.
Yeah. So, I mean, it will get better.
When we do some maths with students, what is important is the result, like you said, and we don't want to make them to be developers. We just want to help them to be able to code something. So programming with blocks is very nice.
Yeah.
It gives us enormous possibilities, and they ils s'approprient la chose tout de suite.
No,
Alors
sorry.
we need another Seymour Papert who can go around proselytizing in the best possible way.
So, Brian, you have
One question. One question. Excuse me.
John should probably say his final piece, and we can keep talking after the video.
Yeah. That's exactly what I wanted to say, because I have to go and I have a 2 hour and 30 minutes video. Perhaps you will see it. I will put it on YouTube. And I wanted to ask John for the last famous words to end the video, because I have to go.
I wanted to thank all of you for coming and for such a great discussion.